Welcome to another deep dive strategy explainer. Okay, let's just get straight into it because today we are tackling something massive. We're opening up an insider's guide to decoding the Cambridge Additional Mathematics exams. Whether you're sitting for the 0606, the 0580, 4024, 4037, or even the 4040, you are in exactly the right place. Today, we're specifically focusing on one of the most notoriously tricky areas of the entire syllabus, finding the domain and range of functions, especially those incredibly frustrating inverse and composite functions. Listen, if you have ever looked at a past paper and felt like you're just staring at a terrifying wall of numbers and letters, just totally paralyzed and hoping the right answer magically appears in your brain, you are absolutely not alone. That's a totally normal reaction to high-level math, but right here, right now, we are going to completely change that dynamic. The core concept you need to grasp today is this. There is no paper, there are only patterns. We are going to train your brain to look past the raw, intimidating numbers and start actually seeing the underlying code of the Cambridge exam itself. So let's kick things off with a pretty hard truth. Why exactly do intelligent, hardworking students lose incredibly easy marks on domain, range, and composite functions? This is the painful reality for so many candidates attempting multi-stage analysis. Let me paint a picture for you. Imagine a student we'll call Alex. Alex is a hard worker, right? Alex walks into the exam, sees a composite function question, and just overloads the page with raw mathematical facts. Just a complete brain dump of everything they know about functions, but with absolutely zero analytical structure. Next to Alex is Sam. Sam is the speedrunner. Sam reads the first half of the question, completely rushes the calculation, and entirely misses the specific command word requirements like show that or determine. And when the results come back, their papers are just covered in red pen marks. They do all the hard computation, they crunch the crazy numbers, and yet the marks just slip right through their fingers. It is incredibly frustrating. The Cambridge syllabus is highly demanding, and the principal examiner reports tell us a very specific recurring story about why students are dropping these points. It is almost never because they don't know basic arithmetic. It's because they get totally lost in the fog of multi-stage analysis. They aren't answering the question the examiner actually asked. But don't worry, because today we're fundamentally shifting how you approach these exact scenarios. And this slide brilliantly illustrates the exact difference between those who merely calculate and those who actually understand the matrix of examiner expectations. On the last side, we have what I like to call the illusion. This is the ultimate trap. It's the belief that the Cambridge exam is simply testing raw computation and memorized isolated facts. It's Alex's approach. But right next to it, on the right, is the code. According to the absolute foundation principles of Cambridge marking, top-performing candidates don't just calculate. They demonstrate a connected, conceptual understanding that is completely transferable to unfamiliar, weird-looking contexts. This is where we need to introduce a framework usually reserved for essay writing, but it's a total secret weapon for math: the PEAL framework. Point, evidence, explanation, link. Top students structure their complex math answers this way. You make your point, like stating the required domain restriction. You provide your evidence, the actual algebra. You give your explanation showing the examiner exactly why that step was necessary to find the inverse. And you link it back to the specific context of the question. When you're dealing with composite functions, plugging one function into another, rote memorization is useless. You have to understand the fundamental principles. Once you see the code, an unfamiliar question isn't a threat. It's literally just a new playground to apply your established rules. Section 1. Decoding the math matrix. Core principles. To actually decode this matrix, you have to understand the underlying framework behind how points are awarded. The absolutely crucial element here is that you must make your mental process visible on the page. This is what we call the method mark strategy. In Cambridge exams, especially additional mathematics, the conceptual framework draws heavily on systematic analysis and evidence-based reasoning. This means the examiners are desperate to see how you arrived at your domain or range. Are you earning points for your systematic process? Are you providing that evidence-based reasoning? Securing those critical method marks is basically your ultimate safety net. Even if you make a silly, tiny arithmetic error at the very end and your final outcome is slightly off, a clear, logical step-by-step process will still capture the vast majority of the marks. You aren't just solving a math problem, you're building a watertight logical argument. And hey, before we continue, subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2. Top Examiner Warnings. We have spent hours digging deep into the principal examiner reports, and they are essentially handing us the ultimate cheat sheet on exactly where candidates blindly fall into traps year after year.
They explicitly flag three main missteps when students deal with inverse and composite functions. First up, the classic trap, using the wrong approach for the given context. You might apply a perfectly valid mathematical technique, but if it's the wrong tool for the specific domain restriction you've been handed, it's completely useless. Second, students constantly forget to check their format and presentation. Mathematics is a language, guys, and presentation absolutely matters. And third, providing answers that aren't specific to the context. Let's bring Alex and Sam back into this. Let's do a live transformation here. Imagine a question asks for the domain of an inverse function representing physical time. Sam rushes it and writes down a range that includes negative numbers. Red mark. But if we guide Sam to pause, apply the method mark strategy, and check the real-world context, suddenly that red pen turns into a beautiful green check mark. Sam realizes time can't be negative, restricts the domain to greater than 0, and secures the bag. This is what we call the mathematics success blueprint. It's about knowing why you are making a change, not just guessing.
And this brings us to an incredibly direct, no-nonsense warning straight from the source. The examiners say, candidates consistently confuse key terminology. Always define terms before using them in extended responses. This direct warning shows exactly why locking down your vocabulary is just as critical as the algebra itself. Do you know the precise difference between the domain of an inverse function and the range of the original function? They are inherently, permanently linked, but if you mix up the terminology in your working, the examiner literally cannot reward you, even if your numbers are right. You have to communicate like a true mathematician. Stop scrolling. Subscribe to our YouTube channel AC Exams at @ACExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @ACExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3, Procedural Frameworks.
Okay, to avoid those exact vocabulary and context traps, top-scoring candidates rely on incredibly strict conventions to present their information. I want you to treat this 4-step timeline as your visual story method for every single function question you encounter. If you follow this, you effortlessly align with the examiner's marking algorithm. Let's do an interactive workshop right now to test this. Challenge 1, data scan. Imagine I just threw a super complex composite function graph on the screen. You have a 60-second visual countdown in your head. Can you extract the core trend? Where are the asymptotes? What's the domain? Boom, time's up. Step 1 says you need proper headings. Signpost what you are doing. Are you finding the inverse now? Actually write the word inverse on your paper. Challenge 2, find the flaw. I'm imagining a flawed sample paragraph from a past paper where students swapped the x and y variables but forgot to state the new domain. Could you spot the sentence losing marks? Yes, it's the lack of step 2, correct terminology. You must use precise vocabulary. Now for challenge 3, speed writing. You have 30 seconds to write one perfect Peel paragraph explaining why a quadratic function needs a restricted domain to have an inverse. Go.
Section 4. Deconstruct, solve, evaluate.
All right, let's unlock the actual master blueprint for top marks. We've talked extensively about how to present your work, but how should you actually think through these multi-stage function problems in the heat of the exam? Following this precise problem-solving protocol demonstrates the elite evaluative thinking that Cambridge demands. Think of it as deconstruct, solve, evaluate. This is your final answering system. There are 3 rules that guarantee top marks here. Rule 1, command word decoding. You must start by identifying the given information and exactly what the verb in the prompt is asking you to do. Rule 2, Peel framework application. Break the composite function down into logical steps and solve it systematically, ensuring you capture every single method mark along the way. Rule 3, the time management matrix. This means you allocate your time based on the marks available, ensuring you have time for step 4 on our screen, check reasonableness. This is where 80% of students fail. If you calculate a range that completely defies the logic of the original domain restriction, you have to catch it here. And finally, make your justified recommendations or final statements. This isn't just math anymore. This is a comprehensive, bulletproof evaluation process.
To truly maximize your score and push into that top tier, you must actively evaluate the quality of your mathematical evidence and justify your decisions. This requires what we call critical analysis mastery. When you are looking at an inverse function, are you instinctively identifying its limitations? Remember, a function simply might not have an inverse unless its domain is artificially restricted to make it one-to-one. You have to question your assumptions. Consider the effect of a restricted domain on your final conclusions. If you change the domain of f of x, the range of the inverse of f of x changes in lockstep. Top-scoring candidates demonstrate this evaluative thinking constantly, on every single page. They never just accept the first number their calculator spits out, they analyze it against the absolute rules of the matrix.
So, as we wrap up this strategy session, I want to leave you with one final critical question. The next time you open a past paper, are you just going to see a random, chaotic assortment of intimidating math problems? Or will you finally see the underlying code? Will you see the hidden opportunities for method marks, the structural frameworks required for presentation, and the precise terminology the examiners are literally begging you to use? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Master the code and take total control of your exams.